Hello my dear students, today we will discuss a very interesting problem on projectile motion. You have a wedge. This wedge is inclined at an angle 30 degree with the horizontal. From the bottom of this wedge, a projectile is fired with velocity 10 root 3 meter per second. The velocity with which the projectile is fired is making an angle 60 degree with the horizontal. At the same time, when this projectile is fired, you have given this wedge a horizontal velocity of 10 root 3 meter per second as well. Now question is, after how much time will this projectile go and hit a point, any point on this wedge? So that is the question. Very interesting problem. Let's see how we can solve this problem. First and the foremost thing, the convenient approach will be, we should consider an observer who is on the inclined plane. So our entire analysis will be about this observer who is on the inclined plane and not about this observer who is on the ground. This is the ground observer and this is the inclined plane observer. That's one thing. Second thing is, we must consider axis. So from this particular point of projection, this point of projection lies on this inclined plane. I must draw axis. So I am considering this to be my x direction. Okay. And this one as my y direction. Now why have I chosen the direction of firing of projectile as my y-axis? What is the reason? You see here, projectile is fired at an angle 60 degree, inclined plane is making 30 degree with the horizontal, so definitely this is 90 degree. Now what do we know? We know unit vector along x-axis is I cap. So you have unit vector by convention I cap in this direction and unit vector along y-axis j cap along this direction. So what is the unit vector along this direction? First of all, if this is 60 degree, this has to be how much? 30 degree. So unit vector along this direction is I cap cos 30 degree plus j cap cos 60 degree. So basically root 3 I cap plus j cap divided by 2. This is the unit vector along this particular direction. So what can I say? Therefore, what can I say? J velocity of a wedge with respect to ground is 10 root 3. That's the magnitude. And direction vector is this into root 3 I cap plus j cap by 2. So if we do the cancellation, 5 root 3 into 3 root 3, that will give me 15 plus 5 root 3 j cap. This is velocity of wedge with respect to ground. If I want to see what is the velocity of the particle, it is projected making an angle 10 root 3 along this particular direction. So velocity of particle also we can find out. So velocity of particle with respect to ground, if we see, so that is 10 root 3. It is projected along y-axis. So 10 root 3 j cap. But what do we want? We want velocity of particle with respect to wedge. So therefore, velocity of particle with respect to wedge is velocity of particle with respect to ground minus velocity of a wedge with respect to ground. So basically this minus this. So 10 root 3 j cap minus 15 I cap minus 5 root 3 j cap. So basically what we are getting? We are getting minus 15 I cap and 10 root 3 j cap minus 5 root 3 j cap. So plus 5 root 3 j cap. So basically this represents the velocity of the particle with respect to wedge. Velocity of particle with respect to wedge is this. So it basically has an horizontal component as well as a vertical component of velocity. So horizontal component of velocity is minus 15 meter per second, vertical component of velocity 5 root 3 meter per second. But mind you, when I say horizontal and vertical, I refer to these axes. This is x-axis and this is y-axis. So about x-axis the velocity is this. Now the question is, when this particular projectile flies and it hits the inclined plane, so this is the point of projection which we have chosen as the origin, and the projectile flies and hits a point on the inclined plane. So basically the surface of inclined plane is my x-axis. So when the projectile flies and hits the inclined plane, it goes and falls on the x-axis only. Now if it falls on the x-axis, then what is its displacement along y direction? Obviously the displacement along y direction has to be 0, right? So displacement along y direction must be 0. That means Sy must be 0. So what is this Sy? So Sy equals to 0. What does it? What can we write? Velocity of projectile with respect to wedge, its y component into the time of flight. Okay. Now if you are taking velocity of the particle with respect to wedge, then you must take the acceleration of the particle with respect to wedge also. So if we see that the particle is here, what are the forces? What is the acceleration? First of all, acceleration due to gravity is acting in this direction, g. Then along this direction, what will we get? G cos 30 degree. And along the slope of inclined plane, what do we get? G sin 30 degree. So G sin 30 degree is along the slope. G cos 30 degree is perpendicular to the slope of the inclined plane. And this G cos 30 degree is basically opposing the y motion of the projectile. So velocity of projectile with respect to wedge, y component into t minus half G cos 30 degree into t square, and this is equals to Sy, and that Sy is how much? 0. So what is the y component of velocity? 5 root 3. So 5 root 3 into t is equals to half g is 10, cos 30 is root 3 by 2, t square. So what we can say, root 3 cancels, 5 2s are these two cancels, and here also we can take t common. So basically what we are getting, we can take that t minus t square by 2 is equals to 0. So if I take t common, so t is not equals to 0. So therefore what will be the value of t? 2 seconds. So the time after which, the time interval after which the projectile flies and hits a point on the wedge is 2 seconds. So your answer is 2 seconds. So that's the most important concept that we see here, that when the projectile is flying, you have to consider its motion with respect to the wedge, because the projectile is hitting the wedge surface only. If you do that, if you consider the motion of the projectile with respect to this wedge observer or the inclined plane observer, so I can write this observer as W, wedge observer, then I can say that its vertical displacement is 0. Vertical, by vertical I mean vertical with respect to inclined plane. That means Sy is 0. Why? Because it comes to the same surface, inclined surface. Alright, and on the this is the x-axis. So when you reach any point on the x-axis, what is the vertical displacement? Of course it has to be 0. The y coordinate has to be 0. Right? So this projectile hits the wedge after how much time? After 2 seconds. So this is a very, very important concept. And this is another very important concept when you consider any point on the projectile. Then acceleration, means the acceleration components are like this. This is the acceleration of the projectile with respect to wedge, the y component. Okay, so g cos 30 degrees acting along minus j cap direction according to our choice of coordinate system, and g sin 30 degrees acting along I cap direction. Okay, so this particular acceleration is of acceleration of the particle with respect to the wedge. So when you say Sy equals to 0, it is initial velocity of the particle with respect to wedge y component into t minus y minus, because g cos 30 degrees is retarding this motion, minus acceleration of the particle with respect to wedge y component into t square. I hope you understood the solution of this problem. This particular solution, it actually combined the concepts of projectile motion, relative velocity in a very interesting manner. So I hope this cleared certain fundamental concepts of projectile motion. Thank you everyone.